Hello, students. Let me check if it is getting recorded. Yeah. So, welcome to this video. In this video, we will solve question number 151 to 160 of binomial theorems and expansions. The link to download the PDF will be in description, as well as at the end, I will show you how you can download and maintain an updated copy of the PDF. I will also show you my question answer website, which I have prepared for you, because YouTube comments are not really good for mathematical discussion. So I will show you my question answer website as well. So without further ado, let's get started. Question 151 says that if sigma r is equal to 0 to the power to 2n, ar x minus 2 to the power r is equal to sigma r is equal to 0 to 2n, dr x minus 3 to the power r, and ar is equal to 1 for all r greater than equal to n, then show that bn is equal to 2n plus 1 cn plus 1. So here we let that x minus 3 is equal to t and x minus 2 will become 1 plus t. So the given expression becomes sigma r is equal to 0 to 2n ar 1 plus t to the power r is equal to sigma r is equal to 0 to 2n dr. So we write this left hand side a0 a1 times 1 plus t and so on up to n minus 1 plus t to the power n. Now it is given that when r is greater than or equal to n, ar becomes 1. So it follows that 1 times 1 plus t to the power n plus 1 times 1 plus t to the power n plus 1 up to 1 plus t to the power 2n is equal to b0 plus b1t plus b2t square up to b2n t to the power tn. Now we equate the coefficient of t to the power n. So it will be ncn plus n plus 1 cn plus n plus 2 cn. All will occur in this side, that is the coefficient of dn. It will go on up to 2n cn. Now we know that ncn is equal to n plus 1 c, n plus 1 is equal to 1. So this we can write as n plus 1 c n plus 1, and we go on summing that. Okay. So if we sum this all the way, now this given expression is equal to n plus 1 c n plus 1 c n plus 1 c, and here cn will be equal to n plus 2 c n plus 1 if we sum these two. Okay. So now we can sum n plus 2 cn plus 1 with n plus 2 cn, that is this term. So that will become n plus 2 c n plus 1, and eventually up to over here, just before this, it will become 2n cn plus 1, and we add the final 2, we get 2n plus 1 cn plus 1. Question 152 says that find the coefficient of x to the power 50 in 1 plus x to the power 1000 plus 2x times 1 plus x to the power 999 plus 3x squared times 1 plus x to the power 998 and so on up to 1001 x to the power 1000. So what we do is we rewrite this and we take 1 plus x to the power 1000 outside. Okay. So this becomes 1 plus 2 times x plus 1 upon x plus 3 times x upon 1 plus x whole square and so on up to 1001 x to the power 1 plus x to the power 1000. We let k is equal to x plus 1 upon x. It becomes 1 plus x to the power 1000 times 1 plus 2k plus 3k square up to 1000k to the power 1000. Now we can write that x is equal to 1 plus 2k plus 3k square up to 1000k to the power 1000, and k is equal to k plus 2k square up to 1000k 1000 plus 1001k 1001. We subtract and eventually we find s to be 1 plus x whole square times 1 minus x to the power 1001 upon 1 plus x to the power 1000 minus 1001 times x to the power 1001 upon 1 plus x to the power 1000. So now we will multiply the whole thing with 1 plus x to the power 1000. So the given expression becomes 1 plus x to the power 1002 minus x to the power 1001 times 1 plus x to the power multiplied with 1 plus x minus 1001 x to the power 1001, and hence the coefficient of x to the power 50 is 1002 C50 from this one. first term. From the second and third term, there will be no power of x to the power 50. Question 153 says that show that ncn plus n plus 1 cn plus n plus 2 cn up to n plus k cn is equal to n plus k plus 1 cn plus 1. So quotient of left hand side is equal to quotient of x to the power n 1 plus x to the power n plus 1 plus x to the power n plus 1 up plus 1 plus x to the power n plus 2 up to 1 plus x to the power n plus 1. Now 1 plus x to the power n plus 1 plus x to the power n plus 1 times, plus 1 plus x to the power n plus 2. What we do is we take 1 plus x to the power n common, we get 1 plus x to the power k plus 1 minus 1 upon x in bracket. Now we multiply the whole thing, we get 1 upon x times 1 plus x to the power n plus k plus 1 minus 1 upon x times 1 plus x to the power n. Now equating the quotient of x to the power n on left hand side and right hand side both, we get it as n plus k plus 1 c n plus 1. Question 154 says that find the quotient of x to the power n in 1 plus x plus 2x square plus 3x cube up to n x to the power n whole square. So we let s is equal to, okay, seems to be a typing mistake. This should be 1 plus, right? Okay. What to do here? Let me think. So if it is 1 plus x plus 2x square plus 3x cube plus nx to the power n, xs will become x plus x square plus 2x cube. So let's assume that s is equal to x plus 2x square plus 3x cube plus nx to the power n, and xs will become x square plus 2x cube and so on up to n minus 1 times x to the power n plus nx to the power n. We subtract, we get 1 minus x is equal to x plus x square plus x cube up to x to the power n minus nx to the power n plus 1. So s becomes x times 1 minus x to the power n upon 1 minus x whole square minus nx to the power n plus 1 upon 1 minus x. Now we need 1 plus x plus 2x plus 3x cube plus nx n to the power whole square is equal to 1 plus x times 1 minus x to the power n 1 minus x whole square minus nx to the power n plus 1 1 minus x to the power 2. So this is this, but our series is 1 plus x. So both are correct. We add 1 here. So 1 gets added to this. Now we need quotient of x to the power n is equal to quotient of x to the power n in 1 plus x upon 1 plus x square whole square, living terms containing power of x greater than n. So this will be power x to the power n, it will become, and this is also x to the power n plus 1. The quotient of x to the power n in 1 minus x to the power minus 2 plus 2x times 1 minus x to the power minus 2 plus x square 1 minus x to the power minus 4. This is equal to 2 times n c n minus 1 plus n plus 1 c n minus 2, which you solve and you will arrive at n times n squared plus 11 upon 6. Question 155 says that find the quotient of x to the power k where k is between 0 and n in the expansion of 1 plus x plus 1 plus x whole square and so on up to 1 plus x to the power n. So we sum the series, we get 1 plus x to the power n plus 1 minus 1 upon x. And quotient of x to the power k is equal to quotient of x to the power k plus 1 in 1 plus x to the power n plus 1, which is equal to n plus 1 c k plus 1. Question 156 says that find the quotient of x to the power 3 n x plus 1 to the power n plus x plus 1 to the power n minus 1 times x plus 2 plus x plus 1 to the power n minus 2 times x plus 2 whole square and so on up to x plus 2 to the power n. So it's GP, the terms are a GP with first term being x plus 1 to the power n and common ratio x plus 2 upon x plus 1. So we sum the series, it becomes x plus 1 to the power n times x plus 2 to the power n upon x plus 1 to the power n minus 1 upon x plus 2 to upon x plus 1 minus 1, which is equal to x plus 2 to the power n minus x plus 1 to the power n upon 1 plus x plus 1. That is x plus 1 times x plus 2 to the power n minus x plus 1 to the power n. Now quotient of x to the power 3 in this x plus 1 times x plus 2 to the power n minus x plus 1 to the power n is equal to quotient of x square in x plus 2 to the power n minus x plus 1 to the power n plus quotient of x to the power 3 in x plus 2 to the power n minus x plus 1 to the power n, which is equal to 2 times, nc2 n minus 2 times 2 to the power n minus 2 minus nc n minus 2 plus nc n minus 3 times 2 to the power n minus 3 minus nc n minus 3, it is equal to n plus 1 c3 times 2 to the power n minus 2 minus 1. Now we move on to question 157. It says simplify 8 plus 2 upon a to the power 2 by 3 minus a to the power 1 by 3 plus 1 minus a minus 1 upon a minus a to the power half whole to the power 10 into a binomial and determine the term independent of a. So with this given expression, we can write as a to the power 3 plus 1 minus square root of 8 plus 1 upon square root of a. That is a to the power 1 minus 3 minus a to the power minus 1 by 2 whole to the power 10. We let r plus 1h term to be independent of a, then tr plus 1 is 10 cr, a to the power 10 minus r upon 3 and minus a to the power minus r upon 2. So for the term to be independent, 10 minus r upon 3 minus r upon 2, it should be equal to 0. That is 20 minus 5r is equal to 0. Or r is equal to 4. So the term independent of a is T5 is equal to 10C4 or 210. Question 158 says that find the quotient of x square in x plus 1 upon x to the power 10 times 1 minus x plus 2 square. So quotient of x square in the given expression is equal to quotient of x square in x plus 1 upon x to the power 10 minus quotient of x in x plus 1 to the power 10 plus 2 times quotient of term independent of x in x plus 1 upon x plus 1 upon x to the power 10. Now we consider r plus 1x term in the expansion of x plus 1 upon x to the power 10. So tr plus 1 is equal to 10 cr x to the power 10 minus r x minus r. So power of x is 10 minus 2r. Now if 10 minus 2r is equal to 2, r is equal to 4. For 10 is equal to 10 minus 2r is equal to 1, we don't have integral r. And if 10 minus r 2r is equal to 0, then r is equal to 5. The final answer would be 10c4 plus 2 times 10c5. That is 714. Question 159 says, let's find the quotient of x to the power 4 in the expansion of 1 plus x minus 2x squared to the power 6. So we write this as 1 minus x to the power 6 times 1 plus 2x to the power 6. Okay, let me see if the factorization is correct or not. Looks like the factorization is correct. Now we expand both the binomial terms. 1 minus x to the power 6 becomes 1 minus 6x plus 15x squared and so on. And 1 plus 2x to the power 6 becomes 1 plus 12x plus 50x squared and so on. So the quotient of x to the power 4 is 240 minus 6 times 160 plus 15 times 60 minus 20 times 12 plus 15 is equal to minus 45. Question 160 says that find the term independent of x in 1 plus x plus 2x cube times 3 upon 2x squared minus 1 upon 3x to the power 9. So we have to find this term independent of x in this given expression. We consider r plus 1x term in the expansion of the binomial term. That is 9cr 3 upon 2x squared to the power 9 minus r times 1 minus 1 upon 3x to the power r. So the power of x would be 18 minus r from here, 18 minus 2r from here, and minus r from here, that is 18 minus 3r. The term is multiplied with 1 plus x plus 2x cubed. So for 1, the value of 18 minus 3r is equal to 0, that is r is equal to 6. For x, the term would be 18 minus 3r is equal to minus 1, which does not give an integral. For 2x cubed, 18 minus 3r would be minus 3, that is r is equal to 7. So the final term would be 9c6 3 upon 2x squared to the power 3 minus 1 upon 3x to the power 6 plus 2x cubed 9c7 3 upon 2x squared to the power 2 and minus 1 upon 3x to the power 7. The sum would be 17 upon 54. So with this, we come to the end of 160 problems. Now I'll show you my website, astroper.org. You can click on second, third, and fourth to download Algebra, trigonometry, and trigonometry PDF. The downloaded PDF will not have date, so you add the PDF date given here in the download PDF. And once in 15 to 30 days, we come back and check whether the PDF date has changed. And if the date has changed, you can download again and update with the latest date. I cannot put date in the PDF because that will make the existing link invalid. Also, if you have questions other than what we solve, you can come on the 8th link. You will arrive at Kunjika, so you make a login area, you can ask questions. And the tags you can use are algebra, calculus, geometry, coordinate geometry, mathematics, probability, and trigonometry. If the subjects do not match, use the generic tag mathematics to ask your questions. So I'll be more than happy to answer your questions on this website. And you can use math here. So right now the Markdown help does not include the mathematical content. I will add the mathematical help over here. Okay. So with this, I will end this video here. I hope that you have enjoyed this video. And if you have not watched earlier videos in the playlist, please go and watch them. So thanks a lot for watching the video. I will see you in the next one tomorrow with 10 more problems. Till then, have a great day ahead. Stay curious, keep learning, and most importantly, enjoy.